In the today's module number 2, we are going to study the information related to comparator. So, starting with comparator, and comparators and angular measurement is the chapter name. We will see chapter outline one by one. What we are going to cover are the key points of this chapter. We will see comparators, introduction to comparators, characteristics, use of comparators, classification of comparators. Now, classification of comparator will comprise of following parts: mechanical comparators that will include dial indicator, Johansson's microgator, sigma comparator. Next, in the next series, we will see optical comparators. That means comparators where optical illusion will give us the comparison process. It is Zeiss ultra-optimeter and basic principles. Next category is electric and electronic comparators, where the most prominent used version is LVDT. Please mention the name LVDT, that stands for linear variable differential transducer. Next is pneumatic comparators. As the word defines, pneumatic comparator will give us the air pressure, and the air pressure will be the key part to determine or to compare unknown with the standard. As we all know, the measurement system is a definition for measurement system is comparison of unknown with standard quantity, and their measurement will give us. That's why the comparator. Pneumatic comparator is defined in two forms as back pressure gauge and Solex comparators. Next will be angular measurements, bevel protector, use of sign bars, sign centers, use of angle gauges. Next, then there we are going to solve different numericals on building of different angles. Now, comparators can give precision measurement with consistent accuracy by eliminating human error. Please keep in mind that human error tends for the false or negative results that are not appropriate. They are employed to find out by how much dimensions of given component either differ from known data. If the dimensions is less or greater than required, already in the last lectures we have seen that if it is a basic size, then there are two dimensions that has to be obtained on an always basis. One is upper dimension, or it is called as maximum dimension. One is lower dimension, or it is called as minimum dimension. So the difference between actual and standard dimension of the workpiece will be measured and will be compared with the standard using comparator. For example, to check the height of job h by 2 with the standard of h1 will give us the accurate result by comparison. Next. Now we can see the comparator working over here. There are two diagrams where one diagram on the left side indicates standard workpiece, whereas diagram B indicates workpiece. Now if we can see, the plunger is in the contact or is in the touch with the standard, and the movement of the plunger is in the vertical direction, that is it is giving y plus y minus direction, and the moment is converted with the help of mechanical bevel gear arrangement, and that will be represented onto the scale on the top. Now since the process of comparator is to be understood, what we are going to follow the system is, first we will have a standard set of block, use of plunger and movement of plunger onto the standard piece will give the readings. We will notify the readings. After that we will put the workpiece in the place of standard. The plunger will be at the same position, and since the workpiece will be having some ups and downs or minimum or maximum dimensions, the readings will be shown in the upper scale. Therefore, we can find out what is the error, that is the topper reading or the standard reading minus or plus the reading obtained from the workpiece. That has been explained over this diagram. advantage is that if H1 and H2 are different, then the change that we have already told, the difference, analog difference between the dimensions will be shown on the dial of the comparator. Thus, difference is then magnified into 1000 or 3000x to get clear variation in the standard and actual job. So this was the example for your understanding. Next. In short, now since you have understand the process, you will get to know comparator is a device which picks up small variations in dimensions. Second, it magnifies it. Third, it displays it by using indicative devices. For example, it can have a LCD display, or it can have a printed solution, or it can have an error that can be clearly visible in the form of digital records. Classification we are going to see. Mechanical comparator works on, as we have already spoken, it works on gear pinion, linkages, levers and spring. Pneumatic comparator works using high pressure air, valves and back pressure. Optical comparator is working on using lens, mirrors, light source, etc. Electrical comparator works using step up, step down transformers. Electronic comparators works by using amplifier, digital signal, analog signal, etc. And combined comparator is the combination of any of the two systems together. We are going to see characteristics of good comparator one by one. Starting with the very first characteristic is it should be compact. Now why it is necessary to be the compactness of the comparator, since the number of workpieces are to be going to be checked in the industry. So if the comparator is having too much space, there is a scope that there is alteration due to temperature, humidity, etc. Therefore, as the system is compact, it will give the accurate result. It should be easy to handle. Now, this handling of comparator by easy is required in two terminology. First is use of skilled labor and use of semi-skilled labor. It should give quick response or quick result. Since it is going to be used in the quality section, so faster results will give to check more number of components. Therefore, it will help to obtain production system. It should be reliable while in use. Since comparator is going to compare unknown quantity with standard, we are totally dependent on the reliability of the comparator. Therefore, it should be maximum reliable. Next is there should not be efforts of environment on the comparator. For example, number of factors like air pressure, humidity, cold, oiliness, dirtiness, dustness, cleanliness, etc. may affect the comparator. Therefore, it is our responsibility to take care of that. There should its weight must be less so that it is easy to handle, or you can call it as a transportation of comparator is easy. Next is it must be cheaper. Now the comparator is a segment which is going to be purchased at a very initial phase. So if it is cheaper, then more number of industries will be thinking for that. It must be easily available in the market, since after sales and after service and after parts or spare parts is the key issue in the industry. It must be easily available in the market. It should be sensitive as per the requirement. There should not be any time lag or any temperature lag or any mass lag that will give us sensitivity on a decreasing load. The design should be robust. Now, if the design is robust, you can get accurately where to the operating manuals are there, where to the working manuals are there. It should be linear in scale so that it is easy to read and get uniform response. Since in the model of error, we have seen in the last lecture that human error, or it is also called as parallax error, that occurs due to improper vision of the person who is operating the machine. So a small variation can cause a large number of deflection over there. So these are the characteristics we have to follow in order to get a good comparator. Next, these three are special characteristics. It should have less maintenance. That means it should work satisfactorily, but maintenance should not occur on a constant time. It should have hard contact point with long life. Now why hard contact point? Because the hard contact point may define number of more components. It should be free from backlash. Now backlash offers after prolonged use, therefore giving number of errors after wear and tear of the comparator. So it should be free from backlash. Now in this lecture we have seen the comparator characteristics as well as what is comparator. In the next lecture we will see all comparators one by one. Thank you.